Welcome back to Everyday Mathematics. Today, we will be looking over problems 6 through 10 from the AMC 2025 AMC 10i. So, problem 6. In an equilateral triangle, each interior angle is trisected by a pair of rays. The intersection of the interiors in the middle 20-degree angle. The intersection of the interiors with the middle 20-degree angle at each vertex is the interior of a convex hexagon. What is the degree measure of the smallest angle of this hexagon? So, here's a poorly sketched diagram, but hopefully it can be useful in determining what the smallest angle of the hexagon. And the hexagon they're referring to is this one, outlined in red. So, what angles do we know, right? Equilateral triangle, the angles are going to be 60, 60, and 60. So if they're trisected, all of these angles are going to be 20 degrees. And we can keep filling them out. And these just all are 20 degrees. All right, so we have that. Let's look at the hexagon. Since this is an equilateral triangle, there's tons of similar triangles and ton of congruent angles. Well, what we can notice is that in this hexagon, these three angles are the same. That just comes because it's, right, from each side of the three sides, everything is congruent. So everything in 3 is going to be equal. And the other 3 are going to be different but equal. So therefore, the one with the 2 dashes is the smaller one. So therefore, it's sufficient to just find the value of one of those. The angle value of one of those. So we're using these 20 degrees. What angles can we find? Well, we have this one triangle, outlined in purple, on the bottom. The sum of the angles in the triangle is 180. So since it's 20 plus 20 is 40, therefore, this angle is also 140. Then we have by vertical angles, this angle is also 140. So therefore, all of these are 140. Okay, that's enough to now we just need to find what the other ones are. The other angles that we actually want to find. To do this, we're going to need the sum of the angles of a hexagon. So the sum of the angles of a polygon with n sides is going to be, n minus 2 times 180. So for a hexagon, when there's 6 sides, say n equals 6, we have the sum of angles. 6 minus 2 is 4 times 180, which is 720. So you have 720 equals 3 times 140. And let's let this angle be x. Plus 3 times x. So we have 720 equals 420 plus 3x. So we have 300. So x is 100 degrees. So the answer is C. Moving on to problem 7. Suppose a and b are real numbers. When the polynomial x cubed plus x squared plus ax plus b is divided by x minus 1, the remainder is 4. When the polynomial is divided by x minus 2, the remainder is 6. What is b minus a? So basically, the key to knowing this, you can know the remainder theorem or just thinking about, right? If this polynomial is divisible by x minus 1, what that means is that when you plug in x equals 1, then x cubed plus x squared plus ax plus b is going to equal 0, But since the remainder is 4 in this case, it's actually going to, equal 4. Well, not necessarily, but for this problem we can set it will equal 4, right? Because if you have something like x squared minus 1, that's divisible by 3. It's divisible by x minus 1, the term. But then if it has a remainder of 4, so like let's add 4 to it, plus 4, right? X squared plus going to be plus 3. Then when we plug in 1, because 1 minus 1 is 0, we're going to get 4. Even if we plug in negative 1, it's going to be 4. So that's kind of the logic behind this. So, right, we have 1 cubed plus 1 squared plus a times 1 plus b equals 4. And similarly, here we can do the same thing with when x equals 2, but the remainder is 6. It's going to equal 6. Because if it's divisible by x minus 2, then it would equal 0. Then we add 6 because of the remainder. So we have 2 cubed plus 2 squared plus 2 times a plus b is 6. So we can calculate the both sides. So we have 2 plus a plus b equals 4. A plus b equals 2. And on the other side, we have 8 plus 4 plus 2a plus b equals 6. So that's going to be 12. So 2a plus b equals negative 6. Now we can just solve a equals 2 minus b. Plug that in. So we have 2 times 2 minus b plus b equals negative 6. B equals negative 6. So we have negative b equals negative 10. So therefore b equals 10. And a equals 2 minus 10 is negative 8. Therefore, we have that b minus a is going to be 10 minus negative 8, which is 18. So our answer is E. Moving on to problem 8. Agnes writes the following 4 statements on a blank piece of paper. At least one of these statements is true. At least 2 of these statements is true. At least 2 of these statements are false. At least one of these statements is false. Each statement is either true or false. How many false statements did Agnes write on the paper? This is more of a logic question, so let's just puzzle it out. Try to figure out what we can learn from each of the clues and if something contradicts itself, and yeah, let's just see what works. Okay. So let's look at the first statement, right? At least one of these statements is true. Well, let's look at the 2 cases. So let's say if it was false, if this is false, right? Then therefore it follows that the bottom must be true, right? Because then, yeah, one thing is false. But then there's a contradiction because then at least one of the statements is true. So therefore, the first one has to be true, which makes sense, right? At least one is true. We're all good with this one. At least 2 of these statements are true. Well, let's look at the same thing. Well, if this was false, then the bottom one is true because that's false. And oh, look, 2 of the statements are true, so this contradicts itself again. So therefore, this one has to be true as well. So these 2 are all taken care of. Now the last 2 are a bit more tricky, right? At least 2 of these statements are false, and at least one of these statements is false. Well, we can look at all the 4 possibilities. They can either be true, 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 false, false, true, or false, false. If they were both true, that wouldn't work, because then the top one's saying at least 2 of these statements are false, but none of them are false. So, similar in this case, you have that it's saying true even though only one thing's false. In the last case, here there are 2 false, but then they both have to be true, because they completely contradict, right? At least one of these statements is false. Yes, in this case they are, but then it's saying it's false, so that's no good. All right, erased. So therefore, right, this makes sense, right? The bottom one, at least, if the bottom one, at least one of these statements is false. Yep, this option is false. And at least 2 of these options are false. Nope, since only one option is false, then this is actually false. So therefore, there's only one false statement. So the answer is B. And the strategy for this is just puzzle around, play around. If there's something that, if you're getting stuck and can't really find logic, it's okay to move on and just go back to it later, because maybe thinking about it more and having a new look at it will help. Okay, problem 9. Let f of x equals 100x cubed minus 300x squared plus 200x. For how many real numbers a does the graph of y equals f of x minus a pass through the point 1, 25? What this equation, y equals f of x minus a, means is basically that's a rightward shift by a. replaced by A. So rather than letting that like complicate things, basically what we can reword this question as is how many values of x, how many values of x exist such that f(x) is 25. Because basically what this does, sorry, f of x. Basically what this right word shift does, right? We can find the value of x, and then we just shift it so that it equals 1. Bye. So let's look at this equation. F of x equals 100x cubed minus 300x squared. Sorry, back. Plus 200x, which equals 25. So we can factor stuff out. 100x times x squared minus 3x equals 2. 100x x minus 1 equals 25. Let's look at just the graph of f of x. Looking at the factored form, right? They're going to, sorry about that. Not great axes. There we go. Right, it's going to have zeros at x equals 0, x equals 1, and x equals 2. And then, so we can draw a rough sketch. It's going to go something like that. This is roughly the graph of fx. Right, because as you approach x equals approach infinity, it's going to go very high, and then negative infinity because this 100x cubed term. And now, right, so 25 is somewhere on this x-axis. So it's either up here, right? There's only one solution. It could be here at the peak when there's 0, then there'll be 2 solutions, or it could be below here when there's 1, 2, 3 solutions. So now all we want to do is find which one of these cases is 1 and 2. And to help us with this, let's plug in what the value is when x equals 1/2. Right? It's x and it's f of x. Or it's like y. So what's f of 1/2? Well, it's going to be 100 times 1/2 times what is 1/2 minus 2? And there 3/2 times negative 1/2. 50. 1 more 2 is going to cancel. So that's going to be negative 75 over 2. Sorry. Is that correct? Sorry. 75 over 2. Let me just check that. 50 times 50 over 2, 25, 75. Yes, that should be right. And this is greater than 25. So since this point is greater than 25, then this 25 is less. There's going to be 2 solutions here with an additional solution there. So we'll throw 3 solutions when f of x equals 25. So there's going to be 3 values of a, like how much you shift this graph so that one of these would be when x equals 1. So the answer is C. Our final problem in this video, problem 10. A semicircle has diameter AB and chord CD of length 16 parallel to AB. A smaller semicircle diameter on AB and tangent to CD is cut from the larger semicircle shown below. What is the area of the resulting figure shown shaded? So, if you notice this problem statement, there's very, very little information actually given about the position of the semicircle. So we're able to make our life a little easier. So let's just draw. This isn't too bad. Assume that's not great. Continuation. Sorry, let me just try this one more time. We have like this line, this is CD. And then we're gonna assume, sorry, the drawing is not great today. We're just change it. We're gonna assume that's actually in the center, this semicircle. And we're gonna let this radius be x. Well then, what's the radius of the this entire circle, of the semicircle? Well, if CD is 16, then you have 8 and 8. So this radius is going to be, in the Pythagorean theorem, square root of x squared plus a squared, which is 64. And that's all we need, right? The area, since these are semicircles, so if the area of a semicircle is going to be pi r squared over 2, because the area of a circle is pi r squared. We're going to divide by 2 because it's a semicircle. So what's the large circle? Pi. What's the radius of the large circle? X squared plus 64 squared. Pi, and then what's the radius of the small circle? X squared. All over 2 because we're dealing with semicircles. So we're going to get pi times x squared plus 64 minus pi times x squared all over 2. The pi x squared is canceled, so we're just left with 64 pi over 2, which is 32 pi. So our answer is C. And that's all for today's video. Hope you enjoyed and were able to learn something new. And yeah, that's it for today. Bye-bye.